out the upper and lower 5% and finds the mean for that middle, in this case, 90% of the data. Tries to take out extreme values. Because it's trying to address the one problem of the mean. The one problem of the mean is the idea of an extreme value. One of my professors in graduate school, my advisor when I first went to graduate school, was telling us about he did his PhD work at Stanford University in the early, mid-'80s. And he was saying, well, I was there at one point, and this is something that you'll have happen to you when you graduate here from Towson at some point, is Stanford sent out a survey to all of their graduates about 6 months after they had graduated. So, sometime in the fall for the spring graduation students. And they asked them a series of questions, how are you doing? Do you have a job? How much money are you making at your job? Would you like to donate money? Things of that nature. And so what they did is they got all this data. So they asked, did they have a job and how much money were they earning on the job? And they also had information about what were their majors and things of that nature. And so what they decided to do was, at the alumni office or wherever, they compiled this data to find out what was the average starting salary based upon major. So they compiled the data. And the econ department was thrilled. Turned out that year, I think it was 1983, graduates, class of 83, that econ was the highest starting salary of any major at Stanford University that year. Now, this is, again, early 80s. The average starting salary for all students at Stanford was something like $20,000. So, but economics had an average starting salary of $100,000 that year. I mean, you would take that salary now. $20,000 might not sound great, but $100,000, heck, I would take $100,000 right now. I know I would make that much. But, so they're like, $100,000, that's great. What are you doing at econ to get people these starting salaries? But, I kind of think say a bit like Sesame Street, where they have, what doesn't belong with the rest. You're seeing that, the next highest major is like chemical or nuclear engineering, and their students are starting at like 27,000. So you're seeing, the next highest is 27,000. You have like engineering people in the mid-20s, and you have 100,000. It just doesn't look right, doesn't fit. So they start to look at the data because someone said, well, maybe you've mistyped in data. You hit an extra 0 or something. Turned out they didn't mistype in any of the data. They'd done all the data entry work right. But then they looked through the responses, and they did actually find that someone had submitted, incorrectly, that his starting salary at his job was $6 million. Turned out that person was John Elway, who still had a horse's face back then. But it's gotten worse over time. Sorry about Colorado. Sorry, he's just... But he had said that his average starting salary his first year was $6 million. He got, a $5-6 million signing bonus and things like that. And so he reported it and said, everything was right. And so, because econ was kind of a small department, there were a ton of econ majors, he pulled up the entire average for the department to 100,000. When you took out a $6 million, the average starting salary for econ majors went down to like 22,000. They were still doing good. It was a good major in terms of starting salary, but it was much more back in line with the rest of the majors on campus. Now, in this case, it's pretty easy to detect what was going on, but this is actually the problem with the mean. The mean is affected by extreme values. Okay? So if you get something that extreme, 6 million, it pulled up the entire average, where the average wasn't a good measure of central tendency. Okay? The idea of central tendency is what's the most likely outcome to occur. Well, the average starting salary of an econ major is not $100,000. Okay? When you looked at it, it meant that you had one person at $6 million above it, and every other person was below that average. And so that's the problem with the mean. And so we have a second measure that we'd like to use, which is the median. What the median represents is the median represents the middle value of your data set. What you do is you take your data and sort it from smallest to largest. So you have the smallest figure to the largest figure, and the median says just find where's the middle of it, and that's your median. Now the nice part about the median is it's completely unaffected by outliers. Okay? And some people would actually argue it may be a better measure of central tendency if you think about where is the center of your data. In this case, our median is 92,469.50. So in this case, the mean is a little bit above the median, about $5,500 difference. So in this case, there is a difference between them, which is telling you in this case that you have some high observations pulling up the mean. Okay? They have some observations that are kind of above that 50% mark. They're pulling up the average by about 5,000. So we'll get to when is this gap between the mean and median really important to pay attention to. Personally, I think you should always report both. You should always report the mean, and you should always report the median. Knowing both pieces of information are good. Sometimes they're the same or very similar, okay? Of which that has some implications. Sometimes there can be vastly different, significantly different. And you have to think about what they mean. A few years ago, I think during the 2004 election, when Bush was running against Senator Kerry, one thing they talked about is there's a lot of debate about were you better off? And President Bush talked about that, for example, the average household income had increased over the first 4 years of his presidency. And Senator Kerry talked about that the median household income had actually decreased during the first 4 years of President Bush's presidency. They actually both were correct. Okay? That President Bush was correct when he said and claimed that the average household income was increasing during his presidency. And Kerry was also correct in saying that the median had actually decreased. And what you can think about as a story here is the median just represents where the middle 50% mark was. And so what we were finding is where that middle 50% mark is, what you want to think about as like maybe the common or typical person, was actually falling a little bit, or showed a slight decline. The mean, on the other hand, represents all of the data. And one thing with income data, and this is always true with it, is your income can't go below zero, but your income can go well above zero. And so what was happening was, during this time, where kind of the average 50% person was falling, the people that were in, for example, the upper 10 and 1% were actually increasing and increasing a lot. And what was going on was, in a sense, as the rich got richer, they were pulling up the average. So where the middle was actually declining a little bit, but because the upper 10% were seeing such increases, they were pulling up the entire average. Now, which one do you trust? Which one do you believe? As I said, both pieces of data were correct. What the conclusions that you draw from it may be different. You know, it depends what you're looking at. If you're looking at the average, you'd say people were better off. If you're looking at the median, you may claim that people were not better off. And then depends upon what you want to do with that